Good afternoon, class. Over the next several minutes, we will be discussing Chapter 3, Section 1, Acceleration. Acceleration is the rate at which velocity changes with time. Since acceleration has a direction associated with it, it is a vector.
In this video, Rowen is accelerating. Notice how he is changing his velocity as time goes on.
We refer to the acceleration of an object at a given instant of time as the instantaneous acceleration. When an acceleration is constant, the acceleration is the same at every instant of time. Average acceleration is the change in velocity divided by the change in time. When an object's acceleration is constant, its instantaneous and average accelerations are the same.
In the previous video, we saw Rowen increasing his velocity as time went on, which is known as accelerating or speeding up. And now we have a video of Rowen decreasing his velocity at the end, which is also referred to as decelerating or slowing down. Before this next clip starts, I just want to introduce the first motion equation that we use, which is VF equals VI plus AT, where VF stands for final velocity and is measured in meters per second, and VI stands for initial velocity, which also is measured in meters per second. A stands for acceleration, which is measured in meters per second squared, and T stands for time, which is measured in seconds. This next clip will show us how this equation relates to the slope-intercept form of a line in a VT graph.
As we stated earlier, the first motion equation is VF equals VI plus AT. You can draw a parallel to this with y equals mx plus b. The slope of the line on the graph would be the acceleration. The t and x are similar because they are the x coordinate, and the vi is equal to the b, which is the y-intercept and the initial velocity.
Rowen starts from rest and moves for 10 seconds at 2.5 meters per second. What is his final acceleration? Our first step is to declare our variables. Anytime it says something is starting at rest, that means VI is equal to 0 meters per second. You're not moving at all. Next we have time, which is equal to 10 seconds. Following that, we have 2.5 meters per second, which is final velocity. What we don't know is acceleration. To find this, we will use the first motion equation. This is because we don't have any position variables, and without position variables, you can use the first one, which is VF equals VI plus A times T. Since we don't know what A is, we have to solve for it. So you subtract VI from both sides. You have VF minus VI equals A times T. Then you divide by T on both sides, and you end up with A by itself, with VF minus VI over T equals acceleration. Our final step is just to plug in the numbers for each variable. The final velocity is 2.5, and the initial velocity is 0. So then you divide it by the time, which is 10 seconds, and you end up with 0.25 meters per second squared.